stations. Okay. Since this study is not aimed at comparing the stations, the results are not subject to mandatory sensibility analysis at the level of installation as a whole. Figure shows the purification processes carried out at La Tacunga and Pedro Vicente Maldonado water treatment plants. During the purification, the flow of water from catchment area into the water supply network flows by gravity, so there is no energy consumption during the precipitation and filtration. Therefore, only coagulation, flocculation, and disinfection processes were considered for the assessment. OpenLCA software was used to simulate the systems under study. The CML method was used to transform input and output streams into impact categories. And the exposure categories selected in this study included global warming potential, acidification potential, eutrophication potential, human toxicity potential, terrestrial ecotoxicity potential, and marine aquatic ecotoxicity potential. Okay, and now we have inventory analysis. Is the second stage. At this stage, an inventory analysis of water treatment plant was carried out based not only on information about the energy consumption and the amount of chemicals needed for the purification processes, and also on factor on equivalent pollution factor. Table shows the inventory of chemical reagents and the amount of electricity at each of the studied plants. Both primary and secondary sources of information were used for this inventory. The primary source of information corresponded to the data provided by technical staff of the studied plants, and the secondary source of information corresponded to EcoInvent database designed to provide general benchmarked data on products and processes used at drinking water treatment plants. Okay, and now we have the last stage, impact assessment and interpretation of the results. Table present the general results obtained by applying the environmental indicators for the two studied systems in comparison with the literature data. Regarding, as you can see, regarding the categories, global warming potential, acidification potential, eutrophication potential, and human toxicity potential, the values of the study are either in the range or close to the literature values indicated for the traditional process. However, for terrestrial ecotoxicity potential, the values of this study are below those given in the literature. Okay. Difference between the results and literature values may be related to different operations, drinking water treatment plants included in the traditional process, certain geographical conditions of the place, and changes in the configuration of the water treatment plants. Each process contributes to different impact categories. The next figures present the results of characteristics of LCA processes, which show the proportion of each process in different categories of impact. The exposure profile in the figure shows that approximately 96% of the total amount of human toxicity potential, acidification potential, and terrestrial ecotoxicity potential is formed during the coagulation flocculation process. About 98% of the total amount of marine aquatic ecotoxicity potential is accounted for by the coagulation flocculation process, and the coagulation flocculation process accounts for 94% of the total amount of global warming potential. According to the results of the figure, at water treatment plant located in Pedro Vicente Maldonado Canton, approximately 94% of the total amount of human toxicity potential and eutrophication potential is formed from polyaluminum chloride or PAC and caustic soda. About 93% of the total amount of acidification potential is accounted for by the coagulation flocculation process. About 98% of the total amount of terrestrial ecotoxicity potential and marine aquatic ecotoxicity potential is accounted for by coagulation flocculation, and about 87% of the total amount of global warming potential is accounted for by the coagulation flocculation process. In conclusion, let me briefly go through the main things again. The greatest environmental stress or hotspots of the study of the studied systems occurs during coagulation flocculation process due to the use of coagulant agents, for example, polyaluminum chloride or aluminum sulfate, and pH stabilizer, such as caustic soda. At the Latacunga water treatment plant, aluminum sulfate has the largest environmental impacts, while at the Pedro Vicente Maldonado water treatment plant, the contribution of PAC is 65%, 52, 60, and 62% of the total warming potential, acidification potential, terrestrial ecotoxicity potential, and marine aquatic ecotoxicity potential, respectively. And the best way to reduce the amount of coagulant is to analyze the effectiveness of a pretreatment process designed to improve the physicochemical characteristics of water entering the water treatment plant. And that's all. Thank you for your attention.
All right, thanks, Christian. That was really interesting. Maybe if you could leave your slides up, we can go back and we can look at some of them if anyone has any questions. But
okay.
Yeah, I think that was really really interesting. I have some questions, but why don't we open it up to the floor and see if anybody else has some first. If you have a question, you can either put it in the chat or you can just unmute and ask the question. Okay, I have two questions.
Okay.
So yeah, so I guess starting with your conclusion that the best way to kind of improve this is sort of pre-treatment processing. What are ways that you can go about doing that? I don't know anything about the system, but it seems like the water comes off from a source, right? And then it gets to the water treatment plant. Is there anything that you can do in between those 2 points, or for like pre-treatment to help kind of reduce the amount of the chemicals you have to use for the coagulation and flocculation process?
Okay, as you know, coagulants and flocculation processes are used to remove colloidal impurities. For example, suspended particles such as bacteria, clays, and organic matter from the contaminated water. Efficient techniques for the removal of highly toxic organic compounds from water have drawn significant interest. A number of methods such as ozonation, adsorption, ion exchange, reverse osmosis, and advanced oxidation processes have been used for the removal of organic pollutants from polluted water and wastewater.
That's really interesting. So presumably, using a similar framework or maybe like a cost benefit analysis, like my guess is they're probably using these chemical. I would imagine it's like the cheapest, most efficient way to do it. And it seems like these probably work really fast, which is if your main thing is to get as much clean water out as possible for as cheaply as possible, I would assume that they're probably already doing the best that they can. I was just interested in potentially, other processes. So these like aluminum sulfate and the polyaluminum chloride, then do these like physically bind to the sediment particles and drop them quicker, or yeah, okay.
Yeah.
Cool. And then I'm guessing like most of the toxic effects of them for like aquatic toxicity and everything like that comes from just those chemicals don't get removed and they get passed to sort of downstream systems. Is that right?
Yeah, actually, these methods have been found to be limited since they often involve high capital and operational cost. On the other hand, for example, ion exchange and reverse osmosis are more attractive processes because the pollutant values can be recovered along with their removal from the effluents.
Yeah. That's really cool. Can you go back a couple slides? There's a figure or two when I had some questions. So um I think I understand, most of these. I was sort of really interested in the thinking about the global warming potential. So I always think about like mechanisms, right? So it's like I'm trying to figure out how the caustic soda, and those two chemicals, like how they might contribute to global warming.
Okay, the process or caustic soda contributes contributes to damage the environment, because to produce caustic soda, you need a lot of fuel, you need energy consumption, and these items have an impact on the environment.
Yeah, okay. So I get it. It's sort of it's an indirect effect of the manufacturing.
Yeah, uh-huh. Yeah.
I think that's why this whole life cycle assessment is so important, right? You're not just considering um like what happens at the treatment plant necessarily, but like if you're going back and thinking, hey, how these chemicals are made, sort of what's going on. Yeah, to me, I guess that's the overall strength of this approach, and there's similar stuff like that for agricultural production and stuff, right? It's like what's your, like you can go from, the very beginning to like, planting a seed in the ground till someone, eating something on their dinner table, and that's why I really like these kind of holistic assessments. And I was excited to see your talk because I think yeah, that really comes through. That's a pretty important
Yeah.
factor there.
This method or LCA provides a systematic basis for preventing partial optimization, shifts environmental impact between the stages of the life cycle, and also helps to identify the main environmental contributors.
Well, that's very enlightening. Thanks so much. Does anybody else have any questions or anything for Christian? Okay, well, if you do and you don't feel comfortable, asking or whatever right now, or if something pops in your head later, Christian's email is on our email chain. So feel free. I'm sure he would love to have any more questions. You can reach out to him. Yeah, and thanks so much for Christian for showing up. I think that was probably our best attended seminar, so that's a great way to end the year. Thanks so much for you for showing up, but also all of your Russian colleagues. We're happy to have you all and host, and yeah, hopefully continue showing up. If anybody yeah, if anybody, any of your colleagues or anybody else that's new to this call wants to be part of the mailing list and see other talks, like feel free. You can email me. I'll put my email in the chat. Yeah, and like I said, so thanks everybody for showing up. We're going to continue this seminar series. I think it's been really really useful so far. We're going to continue it throughout next spring. So I think our next two talks, we are going to have some of my people, some elemental people and ecology nerds that are going to show up and do some stuff. So yeah, so we have two speakers right now on the slate, and we're getting some other ones. So yeah, we'll have some talks about sort of from Krista Capps at the University of Georgia and her colleague down in Mexico about sort of exactly what we want to do, kind of establishing these linkages between US researchers and those in Mexico. And then we have a really fabulous scientist, Cici Las Ponderosas, and she's from Argentina, and she does really, I don't even know what she's going to talk about, but she studies freshwater environments, and she does a lot of really cool stuff with some of the creatures that I grow in my lab. So we're really excited about that, but whatever she talks about, it's going to be pretty awesome. So we have those. If you have any suggestions of people that you might want to see, or any sort of particular topics that you might want to see discussed, I'm free to, just send me an email, and I would love to invite some more people. But yeah, so look for an email from me, and I will see everybody in January. So thanks so much for showing up. It's been a really fun seminar series so far. So and thanks very much, Christian. That was you've been very patient with me while I've been organizing everything. Yeah. So
thank you for the opportunity.
Yeah.
Thank you, dear students, for connected. Спасибо большое.
All right. Bye. Good evening.
Okay. Bye.
Thank you. Goodbye.